Reference angles, Algebra 2, trigonometry regions. So every angle greater than 90 degrees can be expressed using an acute reference angle. And this relates to how we've been drawing triangles in our quadrants and so on. So let me quickly recap that. That in quadrant 1, we know we draw an angle in quadrant 1 is less than 90 degrees. The angle's here and so on. And we know that in quadrant 1, all the angles are between 0 and 90 degrees. So they're already acute. So in quadrant 1, we don't have reference angles because they're already acute. It's the other quadrants, quadrants 2, 3, and 4, that we get angles larger than 90 degrees, so we reference them as acute angles. So let me draw those other quadrants for you and explain what I'm talking about. So let's look at an angle in quadrant 2. So an angle in quadrant 2 looks something like this. And remember, it opens up like this from the positive x-axis, and that's how we would draw a sketch of an angle in quadrant 2. Let's say this angle is 150 degrees. You know, that's between 90 and 180. And it's important to always remember that this um, axis here, that would be a full 180 circle. That's going to be really useful in a lot of what we're talking about today. So a 150-degree angle looks like that. Remember, what we do is how we draw our triangles in these quadrants is we draw them to the x-axis. And we've been putting theta in the origin as that little acute angle right there. So what we can do for a 150-degree angle, instead of thinking of it as 150 degrees off the x-axis over here, I could think of its distance off the x-axis over here. And that's what a reference angle is. So instead of thinking of this as 150 degrees from this x-axis, I could think of this angle as 30 degrees off this x-axis. Because together 150 and 30 form the full 180 circle. Let me actually draw this picture slightly larger for you. So again, this angle right here, that if this is 150 degrees from this axis right here, that's 150 degrees, this would be 30 degrees off of this axis here, because you know this is 180, and together they need to add to 180. So this is what a reference angle in quadrant 2 looks like. That when we have angles in quadrant 2, we know they're in quadrant 2 because they're between 90 and 180. What we can really say is, instead of how far is it from the positive x-axis, how far is it from the negative x-axis? Because that's how we draw our triangles. And so basically, we want to know, how short of 180 is it? So in quadrant 2, the rule for reference angles, and this is what this is angles in quadrant 2. This is just kind of a symbol for in the set of quadrant 2 angles. So don't worry too much about that symbol. It's just saying angles in quadrant 2. For angles in quadrant 2, 180 minus theta. And what this is really translating to is how short of 180. Short of 180. How short of 180 is the angle? So for an example, an angle of 150 degrees, that's 30 short of 180. It's 30 degrees away from the 180 axis. So a 150 degree angle, we can reference it as a 30-degree angle. And they'll have a lot of similar properties. Okay, let's talk about the other quadrants. So in quadrant 3, get an angle like that, and it comes all the way over around here. Well, instead of thinking of it as, let's get an example here. Let's say 210. So let's say this whole angle here is 210 degrees, but it's 210 degrees from the x-axis here. How far is it from the x-axis here? And because we draw our triangles and because we know this is 180, well, 210 is 30 past 180. And so I could think of 210 as a reference of 30 degrees. So it's all about how far is it from the x-axis. And again, a quadrant 1 is going to be a acute angle from the x-axis here, so we don't really worry about it. But quadrants 2 and quadrants 3 and quadrants 4, they're more than 90 degrees from the x-axis here. So we can just simply say, all right, well, how far are we from the x-axis in other locations? And so the rule in quadrant 3 is you do your angle minus 180. How much past 180? So how short of 180 are you in quadrant 2? how much past 180 are you in quadrant 3? It's like an angle of 210. We know it's in quadrant 3 because it's between 180 and 270. Well, I just take that and I minus 180 from it. That'll tell me how much past 180 I am. And then lastly, in quadrant 4, the angles in quadrant 4 look like this, and they're, something like 330 degrees away. So a 330 degree angle because it's between 270 and 360. Well, 270 degrees from this x-axis going counterclockwise. Well, it's also only 30 degrees short of 360. And so in quadrant 4, we tend to ask, how short of 360 are you? How short of a full circle? And so this is how reference angles work, and it's because that's how we draw our triangles, right? We draw our triangle in quadrant 1 like that, our triangle in quadrant 2 like that, quadrant 3 like that. I'm sorry, it's just sloppy. In quadrant 4 like that. But again, in quadrant 2, we want to know the angle, how close it is to the 180 axis, and the same thing in quadrant 3. How close is it to the 180 axis? In quadrant 4, remember this spot right here is 0 degrees when you're talking about angles in quadrant 1, but it stands for 360 when we're talking about angles in quadrant 2. So really, it's just kind of these are some rules you need to just memorize. That if you have an angle in quadrant 2, it's 180, minus it. How short of 180 is it? In quadrant 3, how much past 180 is it? And you could do that by subtracting 180. And in quadrant 4, we don't use the 180 axis because we're closer to the positive x-axis, which is our 0, 360 axis. So we say, how short of 360 is it? These are common reference angle families that you're going to see a lot over the next couple of weeks. That 30 degrees, 30 short of 180 is 150. 30 past 180 is 210, and 30 short of 360 is 330. And that's what I used for the examples in all these. For 45 degrees, 45 short of 180 is 135. 45 past 180 is 225, and 45 short of 360 is 315. For 60 degrees, 60 short of 180 is 120, 60 past 180 is 240, and 60 short of 360 it's 300. And these come up a lot. So if you see these, you really need to remember that these are references of 30, 45, and 60. So if I see 315 at all, I'm thinking about 45. If I see 240, I'm thinking about 60. If I see 150, I'm thinking about 30. But a lot of it is just realize, all right, what quadrant am I in? And if I'm in quadrant 1, if I'm in quadrant 2, how short of 180? Quadrant 3, how past 180? Quadrant 4, how short of 360? So let's get to a couple of examples of the type of problems you'll see. So for the function sine 150, determine the quadrant. All right, so 150 degrees, it's between 90 and 180, so that is quadrant 2. Determine plus or minus for that function in that quadrant. So now I'm thinking, all right, sine in quadrant 2, and if you remember your ASTC from the previous lessons, in quadrant 2, sine is positive. So sine is positive in quadrant 2. State as acute reference. So what we do is we're going to write this as positive sine, and I want to turn 150 into an acute angle. And so the rule in quadrant 2 is when we have an angle in quadrant 2, how short of 180 is it? So 150 degrees is 30 degrees short of 180. And the way to do that algebraically is 180 minus 150. And so we get 30. So if you're in quadrant 2, 180 minus what you have. How short of 180 is 150? The answer is 30. So our answer here is positive sine 30. This little plus sign that I'm putting here, we know we don't need to put a plus sign in front of positive numbers. Right now I'm just doing it to emphasize positive. But our calculator can check this, that if you type in sine 150 and also type in sine 30, you're going to get matching values here. Let's do another example. Here, tangent 320. Tangent 320. 320 is in quadrant 4. And tangent, tangent's positive in 3, but it's negative in 4. So the answer is negative. So this is going to be written as negative tangent. And the rule in quadrant 4 was how short of 360 is it? So I could do 360 minus 320 to get 40. So negative tangent 40 is my answer. And again, let me check it on my calculator. I'm going to type tan 320. But this time I need to type negative tan 40. And that's how that's going to match up. So really a lot of it's just remembering these rules. Let me write them down for you one more time. In quadrant 1, you're good. In quadrant 2, if you get an angle in quadrant 2, 180 minus your angle makes it acute, because that's how short of 180. In quadrant 3, how much past 180 are you? So it's your angle minus 180. And in quadrant 4, it's about the 360 line, so it's how short of 360 are you. So if you have an angle in quadrant 4, you do 360 minus it to make it acute. It's all about making the angle acute, but you need to determine based on the function and the location if it's going to be a positive or negative in front of that case. The previous case, it was positive because we were in quadrant 2 where sine's positive. But in this case, it's negative because tangent's negative in quadrant 4. One more quick example in radians. So cosine 5 pi over 4. I think what most people will do here is they'll probably convert it into degrees. So this is the same thing as cosine. Let's see, I can make this as 5 times 180 divided by 4. 5 pi divided by 4 is the same thing as 225. So cos 225, that's in quadrant 3, where cosine is negative. So I'm looking at a negative cosine acute angle. The rule in quadrant 3 is your angle minus 180. So 225 minus 180 tells me this is a 45-degree reference. So negative cos 45. And let me just check it real quick. That's cos 225 versus negative cos 45, and they do match up. Now, one last thing, that if I start in radians, I should end in radians. So I should convert this into a radians, and I won't go into that lesson now because we've talked about that, but it's going to end up being negative cos pi over 4. Okay, that's it. We'll practice this more tomorrow.